All right. So number one, you're given the universal sets. Remember, use the universal set. So that's all the elements in the set we're looking at. And then y'all understand that A, B, and C are subsets, right? We talked about subsets. Or is a proper subset? Yes or no? For your quiz next week, is A proper subset? Yes. What? Uh, when would it not be a proper subset? Very good, Steve. Yes, you do. Very good. So the elements of A are not exactly the same elements as U, right? There's some missing elements. But all the elements of A are inside of what? U. So A, B, and C are subsets. They are also called what? Proper subsets. Okay. So let's find the first one. Now listen carefully how we're going to do this. And we had that same conversation in a previous lesson. So we have A union, so the Venn diagrams. So we have A union, and then in parentheses we have B intersects C. Okay, now guys, we had talked about when we have parentheses involved, how to deal with that. So what's the first thing you should look at first? B intersects C. What's inside the parentheses? Okay? So let's go and find B intersects C. So B intersects C. So I'll find that first, right here. All right, so let's find it. So B intersects C. So here's B. So I'm going to write B out. I'm going to go ahead and do it here. So here's B. So B is the set that has the elements A, B, E, and G. Y'all agree? Just reading from the handout. And C is the set that has the elements A, C, and H. What is the intersection of B intersects C? A, and that's it, right? Y'all agree it's just A? All right, so I'm going to put that here. So this right here is this set right here. Now let's talk about A. Let me go ahead and write A out. What are the elements of A? Well, it's B, D, F, and H. And I'm union this with what set? A. Okay, so that's what I have. Now, what does union mean? Yeah, you combine them all, right? Whatever's in one set, whatever's in the other, you put them together. And you only list them once. If they occur more than once, you list them once. So set A had how many elements in it? One. What's the cardinality of set A? What's the cardinality of set A? Four. What's the cardinality of set B? I'm sorry. What's the cardinality of the intersection of B and C? One. They're different elements, so together it's going to have my answer is going to have what cardinality? 5. Okay. So my answer is going to be. So you just union those. So it'll be B. Let's put A first. A. You didn't have to. B, D, F, and H. So that's your answer. So the point of this being that you do what's inside the parentheses first. And at this point, finding the intersection should not be an issue. Finding the union should not be an issue because we've been dealing with this. Okay, let's look at number 2. Or I'm sorry, this was A. Let's look at B. So B, you want to find this: A union B intersect A union C. A union B intersect A union C. Well, now you have 2 sets of parentheses. It doesn't matter which one you deal with first. Let's just go to the one on the left. So A union B. So let me go ahead and list A here. So A is B, D, F, and H. So A union B. So A union B means I'm going to include all the elements in A or all the elements in B together, right? So let's look at A and B and union those two sets. So I'm going to have, so here's A, right here, and here's B. So I'm going to go ahead and put them in alphabetical order. So I have A, B, what else? D, E, F, G, and H. Do y'all agree?
Mm-hmm.
Okay. And notice that one of them is listed in both, so you only list it once. So that's the union of A, union B. So that's the set A, union B. So I'm going to put that here, because if you put it in roster notation in this, it kind of helps sometimes. So I'm going to put that here. So A union B is this. So notice the thought processes we're going through. Okay, I'm going to intersect that with whatever A union C is. So let's talk about A union C. I'm going to go ahead and do that here. A union C. So here's A, here's the set C. Let's union those two sets. So I'm going to use A, B, C, D, F, and H. Is that correct?
Yes.
All right. So whatever's in set A and whatever's in set C, we're going to put them together. So I'm going to put that here. So A, B, C, D, F, and H. And then my final answer is the two that, see those two sets? What am I doing to those two sets?
Why does come on?
Intersecting them, right? What do they have in common? So what's my answer? Okay, A, good. So the answer is going to be A, B, D, F, and H. Is that correct? All right. And notice, guys, I put that in braces. Okay, just don't list it without putting them in braces, all right? Just don't list this without putting them in braces, because you're listing a set. You gotta use that notation. All right, any questions on part B? All right, let's look at C. So C says this. You want to find A intersect B union C. Now, what does that symbol mean right here? C complement. All right, C complement. So just as before, we got to find what's inside the parentheses first. Okay? So I'm going to go off to the side. I'm going to figure out B union C complement. Not B union C, but B union C complement. So do this strategically. What I would do, since I'm dealing with a complement now, what I would do is I would list B first. What are the elements of B? Tell me the elements of B. A, B, E, and G. And we're going to union that with the set C complement. Now remember, what does C complement mean?
Everything that's not in C.
So everything in the universal set except the elements of C. So what I would do to kind of help with this, and it's up to you, but I would list the universal set again. So the universal set was this. Let me go ahead and do that here. So here's my universal set. It's A, B, C, D, E, F, G, and H. Okay? And remember, I'm looking for C complement. First of all, C is what set? A, C, and H. Is that correct? Yes. So C complement would be everything in the universal set except those three. So what you do is you just cross those out. So cross out A. What else do we need to cross out? C and H. So what's C complement? B, D, E, F, and G. Okay, good. And that goes here. So that's C complement. B, D, E, F, and G. Okay? So think strategically as you do these. Notice how I'm writing these. It does help if you think strategically about those. Okay, so now I want to find B union C complement. So now I want to union these two sets right here. So what do I get? A, B, E, I forgot the D, A, B, D, E, F, and G, is that correct? All right, so quite a bit of things you have to go through, but all I found at this point, was this. That's all I found. So y'all agree that, and I could have made a mistake, so help me with this. So that was A, E, D, F, and G. But I need to intersect it with A. Well, what's set A? B, D, F, H. And so the answer then to the original problem, which is this, is what? Looks like just D and F, is that correct? D and F? So D and F are the only elements that those two have in common. See right here? They both have D's and they both have F's. All right? So any questions on that first part? Okay, so the first part's not too bad. You just got to remember some terminology and what symbols look like and so forth, and it does help.
So with the union, you combining it? And with the
Intersection is what they have in common. All right, so it's just kind of like if two roads intersect, then the only thing they have in common is this, the intersection. All right, so just think of it that way. So the intersection is what the elements they have in common. The union is everything. So
complement is like everything that's not.
everything in a your complement would be everything in a universal set except the elements in that set. So if you're looking at C complement, it'd be everything in a universal set except the elements of C. Okay?
So that's the only one that you take away.
Those are the only ones you take away from the universal set. Yep. Yeah. All right. Now, let's look at number 2. So number 2 is where you start filling out a Venn diagram. So look at number 2. So let's look at the directions. So you see you're given the universal set, you're given A, you're given B, you're given C, and you want to put all of those elements where they belong. Okay? You want to put all of those elements where they belong. But before we can do that, we need to have a discussion about what all those intersections mean. You see all these intersections right here? See, we have to have a discussion about what all of this right here means in terms of A, B, and C. Okay? All right, so let's go ahead and do that. I'm going to give you another sheet of paper. Let me just see if I can find it. Okay, so when constructing a Venn diagram that we need for number 2, we have to understand what each of those little parts of this intersections mean. Okay? So remember when we only had two circles in our Venn diagram? So for example, when we had this right here, so we had this universal set. This was A, this was set B. This right here that I'm shading in, what is that? How would you symbolize that? Tell me what you write though. A intersect B, that's what that is. All right, so where those two circles intersect is the intersection of those two sets. Y'all agree? Okay. So when I look at this right here, when I look at this region right here, I'm circling this. I see what I'm doing? Look at this. When I look at that, just that little part, what do you notice about that part I've shaded in? It intersects all three. So that's the only part of the universal set that includes A, B, and C. Okay? That's the only part that includes A, B, and C. See, you can't say this part because this part only includes A and what? C. This part only includes A and is the intersection of A and B, and so on. So what I've shaded in, which is region, I'm going to call this region 5. See right here? Region 5? That's the intersection. This right here is the intersection. I'm going to do this. Let me just write it here. Region 5 is the intersection of A, B, and C. Y'all agree with that part? Okay. So when constructing a Venn diagram, which we're going to need for number 2, you always start out with the innermost part of the Venn diagram. So in other words, you're going to start out with, well, first of all, where do the 3 sets intersect? Okay, that'll be your step 1. Okay? All right, so then, and that's what this says. So step 1 is you find region 5. So you find that first. Okay? And then remember, region 5 is the elements that belong to all 3. So let's go back to our handout and let's do that. So look at our handout. So when constructing this Venn diagram, what part do I try and fill in first? Which part do I try and fill in first? The one where they all intersect. Okay, so that means A intersect B intersect C. Y'all agree? So let's find. So step 1 is to find A intersect B intersect C. So you can look at this and tell me which elements that all 3 have in common. 5 is the only one. Y'all agree? All right, so that's just 5. So I'm going to put 5 right here. So that's where you put 5. Don't put any other number in there, because 5 is the only element that all 3 have in common. That's the only place where you put 5. Okay? All right, so then what we got to do is we got to find where to put some of the other numbers, though. Now here's what I would do. So I noticed that when we came here and I asked you, I said, what does this part right here imply? This right here? I'm going to put little X's here. What does that imply? Okay, so A intersect C, right? But I'm going to ask you this, though. Okay, so A intersects C. Be careful, and we're going to have a discussion. A intersects C would be where the 2 circles intersect. Y'all agree? All right, but doesn't this also include A intersects C? Yeah. So actually, it's this whole thing right here that's A intersects C, isn't it? Yes or no? Yeah. All right. But you're on the right track. That is a thought process you're going to go through, though. So if I'm going to try and fill in this part right here, I know, well, that's where A and C intersect, but they also intersect here. And this is also the place where they intersect with what other set? B. Now look at this again. This part that we're talking about where A intersects C, it does not include what? B. Okay? So y'all see that? A, this part right here, region 4, A intersect C, which really is all this. This part here that I'm looking at, though, is the intersection of A and C, but not including anything that's in B. Okay? Well, we already found, guys, my element that goes in here. What element goes in here? 5. So let's still do this, though. Let's still find A intersects C. You understand? I'm still going to find A intersects C. All right, so let's do that. Watch. A intersects C. So step 2, let's fill this part out. So let's say A intersects C. All right, first of all, Look at A and C. What are the elements in A and C? Oh, I'm sorry, wrong one. What are the elements of A and C that they have in common? 1, 5, and 8. That's it, right? Y'all agree? 1, 5, and 8? All right, now that is A intersects C. Y'all agree with that? So 1, 5, and 8. 1, 5, and 8 goes in all of this right here. Y'all see that? Because this whole thing is really what? A intersects C. But I already filled that part out. So 5 is already in here. So what's left that I have to fill in? 1 and 8. And so where do you think that goes? Right there. Okay. Now I'm hoping that you see this right here. This right here is A intersects C. Right? Yeah, so you see I already have 5. 5 is the one that's in common to all of them, so that's going to stay here. 1 and 8 goes here. Guys, I don't put 1 here. Why doesn't 1 go with the 5? Because 1's not included in all 3 sets. You understand? So step 1 is to find the innermost first. You find the intersection of all 3 sets, and then you work yourself out. Okay? Now use that same thought process. Use that same thought process. Let's find this one. So let's think about that. Who wants to go through the thought process? So we're going to find. So this right here would be B intersect what? C. So let's go ahead and step 3. Let's find B intersect C. What's B intersect C? It's just 5? Okay. All right. Which I already have, right? So do I put anything in here? No. Y'all agree? Don't put anything in there. What's this one here? A intersect B. So let's find A intersect B. All right. What's A intersect B right here? Just 2? 2 and 5, okay. So, but in reality, do y'all agree that this whole thing right here is A intersect B? But this one already has a 5 in, so where do I put the 2? Right here. Okay. So far, I want you to notice this. So far, if you look at your universal set, I've already taken care of 1. I'm crossing it out. I've taken care of 2. I'm crossing it out. I've taken care of 5. I'm crossing it out. I've taken care of 8. So you're trying to place all those numbers in the universal set where they belong. Okay, so I did the innermost first, and I did each of these intersections. Now the rest is easy. Because this right here, what would go in? So y'all agree that all this represents the set. I'm circling. What does all this represent? Set what? A. I've already filled out most of set A. The rest of set A would go where? Right here. So A is 1. A has the elements 1, 2, 5, and 8. 1, 2, 5, and 8. Well, what do you notice about that? It's already in there. So do I put anything in here? No. Okay. Do the same thing here. Same thing here. So this indicates all of what? Set B. Well, B contains 2, 4, and 5. I have the 2. I have the 5. What am I missing? The 4. Okay, I'm going to ask you this. Can I put the 4 here? Because that's also a B. No. Because we saw that dealt with an intersection. So where do I put the 4? Right here. So be careful where you put them. Because remember, we already dealt with that. We're done with this part. And then all this represents what? C. Well, C is 1, has the elements 1, 3, 5, and 8. What's missing? Where do I put the 3? Here or here? Bottom. Good. Right here. Okay? So I filled in all the circles. Everything else goes on the outside. Everything else goes on the outside. So let's see what's missing. I did the 3. I'm going to cross that out. I did oh no. So what am I missing? A 6 and a 7. So I'm going to put the 6 here and 7 here. Doesn't matter where you put the 6 and 7, guys. You can put 6 here, 7 here. It does not matter. As long as where you put them is not in one of the circles. Okay, any questions? All right. So in constructive Venn diagram, where do you start? Where they all intersect. And then you work yourself out, and then you go further out.
So if they belong to, like, the same column, then they don't have anything, like, alright, for instance, A, all the numbers in A belong to C or B, so A doesn't really have anything.
Wait, what? I'm sorry. You're looking at this A?
Yeah.
Okay, what about this A now?
All the numbers belong to a group already, as in B and C, like they murdered.
No, all those numbers are not in all these. Some of them are. I'm not quite understanding what you're asking.
She's saying they all intersect.
They don't all intersect because 8's not in all of them. Was the only if you look at the intersection of A, B, and C was the only element they have in common.
8 does intersect with A and C.
No, she's saying all of them.
No, I'm saying like all the numbers intersect with something, like 1 and 8 intersect with C, and 2 intersect with B, and 5 intersects with all of them.
Okay, so I agree that five isn't all sets. So the intersection of all sets is 5. That is true. So that's why we put that here.
Right.
But what?
Never mind.
Yeah, I'm not.
She's saying that since everything in A intersects with something, she was asking you to leave A blank the other side, you know?
Oh, I see what she's saying. Oh, yes. That's a good point. So she's saying that every element in here is somewhere in the other two.
Right.
So they're going to be dispersed in this little area here. Yes, that is true. That's a good observation. Yes. So that's why you wouldn't have anything there. Yeah. You see what she saw? That is a good observation. So, for example, if I had put, and I hate to mess this up, but if this thing was a 9 here and this was a 9, I put a 9 in universal set and this was a 9, then where would that 9 go? Right here. Okay? You see that? All right. So that was the observation she was making, and yeah, that's a good point. Very good. Yeah. All right. So, any questions at this point? All right. Let's see. I think there's a back page. Nope. Yep. There's a back page. So let's go to the back page. So this is number 3. So you're told that the universal set is this. Now remember those 3 little dots, what does that imply? What's the word for that? Ellipses. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Set A only has 3 elements, 3, 5, and 7. Set B has 4 elements, 1, 3, 6, and 8. Set C has 3, 4, 8, 9, and 10. Okay? So what I'd like for you to do first, before we actually do A and B, is I want you to construct the Venn diagram. So let's see if you can remember the processes to go through. So here's A. Do it like this. Draw this Venn diagram. Here's B. And then here's C. So go ahead and take about, it won't take you long because there's not many elements here. And you're dealing with numbers, so it's a little bit easier to deal with rather than alphabets. Go ahead and take about 3 to 5 minutes to fill in that Venn diagram. All right, so when constructing this Venn diagram, do the innermost first, so where those three sets intersect, A, B, and C. So what do A, B, and C have in common?
3.
Is that the only one? All right, goes here. Okay. Then let's do this one first. It doesn't matter, guys, whether you do this one, or this one. Does not matter. You're kind of like starting in the middle and then working yourself out. Let's talk about this one. So this whole thing right here represents the intersection of A and what set?
C.
C. Okay? And so when I look at A intersects C, that is 3, just 3, right? Is that correct?
No.
No? He said no. Why'd you say no?
Okay, 3. Yes.
Okay, 3. But 3's already here, so can I use it again?
No.
No. So did y'all have yours blank? Okay. Then let's look at this one. So let's look at this right here. Let's think of this in terms of B intersects C. So B intersects C would be 3 and 8. Is that right? But 3's already here, so I'm going to put what here? 8. Now let's look at this one. So this would be A intersect B. So A intersect B, that's 3, right?
Yeah, 3.
But we already have a 3, so you don't put anything in there. Okay, so that took care of that part of the Venn diagram. Now let's go on the outside right here. So this right here, think about it this way. This right here is all of set A. So if you look at all of set A, that's this. I already used up the 3, so what's missing in set A? But where must I put 5 and 7? Here or here? Right there. 5 and 7. I don't put it here because that would imply that 5 and 7 are also in C. It's 5 and 7 in C. No. So this right here indicates all of set B. Well, B has the elements 1, 3, 6, and 8. So what's missing? 1 and 6. Okay? This right here implies all of set C. Well, set C has all of these elements. I've already used up 3 and 8. So what goes here? 4, 9, and 10. And then you got to just remember, though, you still have that universal set to look at. So whatever's missing here, whatever we have here that's not here is what goes on the outside. So what's the only element that's in the universal set that's not in here? 2. It doesn't matter where you put the 2. Okay? All right, so that was that. Now let's look at part A. So the first thing you wanted to do is construct a Venn diagram. Now let's look at 3A. So 3A, you want to find A union B complement intersect C. So A union B complement intersect C. All right, well, first of all, what we got to find?
A union B.
A union B, right? A union B. Well, look at the elements in A, look at the elements in B, and let's combine them. So it's A union B. 1, 3, 5, 6, 7, 8. Very good. So that's A union B. But now I got to find A union B complement. So A union B complement, remember what that means? That means everything in the universal set, but not including which one?
B.
A union B. So I'm going to rewrite the universal set again. So here's my universal set. My universal set is 1, 2. I'm actually going to list all the elements all the way to 10. So A union B complement would be everything in the universal set, but not including these. So I'm going to take 1 away. I'm going to take 3 away. 5, 6, 7, and 8. So what would be A union B complement? What about the 2?
Oh, yes.
Yeah, 2, 4, 9, and 10. So I'm going to put that here. So I'm going to put this here. So 2, 4, 9, and 10. And I'm going to intersect that with C. Well, what's C? C has what elements? 3, 4, 8, 9, 10. So what's the answer? What's the answer? 4, 9, 10. That's your answer. All right, so that's 3A. And then finally 3B. Look at B, 3B. You have A complement intersect B complement intersect C. So A complement intersect B complement intersect C. So let's do that in steps. What's the first thing you look for? The parentheses. So inside the parentheses, you have B complement intersect C. Now, what I would do, the way I would do that is I would list those in roster form. So B complement means everything in a universal set, but not including the elements of B. So let me go ahead and rewrite the universal set, because sometimes it helps if you rewrite it and just cross things out. So I'm going to go ahead and list those. All right, now I want to find B complement. So B, remember, is, let me just write B. So B is this. So B has the elements 1, 3, 6, and 8. So B complement would be everything in a universal set except those that I'm removing. So what's B complement? 2, 4, 5, 7, 9, and 10. Is that right? Okay. Intersect, and then C. What's C? C is 3, 4, 8, 9, and 10. So that was set C right here. And then all you do is look for the intersection. So what is this right here? 4 and 9s are the only one? Yeah, so that's 4 and 9. Okay? All right, any question on how we found that parentheses? But then I got to intersect it with a complement. So you go through that process. So you got to intersect this with a complement. So let's find a complement. Well, we got to look at the universal set first. So here's my universal set. Again, it's 1, 2, 3, all the way to 10. And then here's A. I'm going to list A. So A has the elements, the set A has the elements 3, 5, and 7. And so do y'all agree that A complement is all of this except which ones? 3, 5, and 7. So it's A complement. 1, 2, 4, 6, 8, 9, 10. So that goes here. So 1, 2, 4, 6, 8, 9, 10. And then finally, what's the answer? It's the intersection of these two now. So what's the answer? 4 and 9? 4 and 9. Okay? Any questions on that? All right. So that's the end of that little part. Let me give you a worksheet on this to get you just to show you what you have to deal with.